Welcome, Mark Lewis. This was our day 4 question. Here they are saying a line divides an equilateral triangle of side length 1 unit into two parts with the same perimeter and different areas. But they never mention where is this particular line. Okay, so if I'm going to consider the line starting from the vertex doing this, let's see what happens. Being it equilateral, so every side length is totally 1, all sides are equal. I don't know the length of BD, if I keep it x, and TC will become 1 minus x, and AD will become y. We mentioned that both the parts have the same perimeter. If I write perimeter of triangle ABD, this should be equal to perimeter of triangle ACD. Perimeter sum of boundaries, so 1 plus y plus x, it become equal to 1 plus y plus 1 minus x. On solving this equation, we'll be getting 2x equal to 1, x equal to 1 by 2. But if x is 1 by 2, then 1 minus x is also 1 by 2. That means AD line is going to be the median. Because AD is the median. Then both the triangles ABD and ACD will have equal areas. But the question clearly mentioned, they should be having different areas. So from this we understand that the particular line should not be starting from the vertex. So we will assume that line not starting from the vertex, but still doing the same property. I'm just drawing some random line like this, dividing your triangle into two parts, because that's also a clue, because they just said that line is dividing the triangle into two parts. They never mention it to two triangles. Okay, so this point be D and this point be E. If this is x, this will become 1 minus x, and this is 1. And if this is y, which is going to become 1 minus y, and let this portion be z. So the perimeter of this triangular region and this quadrilateral region should be equal according to the question. So I would write perimeter of PVE is being equal to perimeter of ADEC. X plus y plus z is being equal to 1 minus x plus 1 minus y. Altogether get 2x plus 2y is equal to 3. So that tells us the value of x plus y will be e by. Okay. So now we need to find out the maximum ratio between S1 and S2. So out of these two parts, I cannot confirmly say which will be the bigger area and all. Let me call this angle to be 60 degrees. So this triangular region, if I'm going to call it as S1, then the area of the triangle can be as half into product of adjacent sides into sine of angle between them. So this is an area formula for triangle if you know two adjacent sides and included angle. So S2, if this is S1, this is S2. Okay, this region of this quadrilateral will be called as S2, while this will be called as S1. So instead of doing S1 by S2, what we can do S1 divided by the total area of the triangle. Total area of the triangle ABC. We try to get to this first, and if we subtract this from 1, then what will happen actually? From this, if I'm subtracting S1 by ABC from 1, I'll get area of ABC minus S1 by ABC. Okay, so what will be area of ABC minus S1? So that will give us S2, right? S2 by ABC will come. At first, we'll target S1 by area of ABC. S1 is a triangle half into xy sine 60. Sine 60 value is root 3 by 2. Divided by area of equilateral triangle, which we all know by area formula is root 3 by 4 times side square, side being 1, we just 1 square. This is the value of S1 by ABC. So similarly, I'll do S2 by ABC. For that, what did I say? If I just subtract 1 from this ratio, I'll be getting S2 by ABC. 1 minus of S1 by ABC will give us the value of S2 by ABC. Because our triangle ABC is made of S1 plus S2. So this will give us root 3 by 4 minus of root 3 xy divided by 4 divided by root 3 by 4. Think about this, people. If I divide S1 by ABC divided by S2 by ABC, then what we'll be having? We'll be having the value of S1 by S2. Okay. I'm going to clear the first image here. S1 by ABC area. I'm going to divide it by S2 by ABC area. When I do this, I'm getting root 3 by 4xy divided by root 3 by 4. That is getting divided by root 3 by 4 minus root 3xy by 4 divided by root 3 by 4. Root 3 by 4, root 3 by 4 gets cancelled off. So this is what we are left out. So this is our ratio of S1 by S2. So further, I understand root 3 by 4 is common. If I bring out root 3 by 4 common from the denominator, I am left out with 1 minus xy. Numerator also I have the same, root 3 by 4 xy. Root 3 by 4, root 3 by 4 gets cancelled. I'm left out with xy by 1 minus xy. We already have a relationship between x and y. Y is nothing but 3 by 2 minus x. So once you substitute this, x into d by 2 minus x. Thereby 1 minus x into 3 by 2 minus x. Then the question is talking about the maximum value of S1 by S2. So the words maximum, minimum and all are associated with calculus differentiations. We will simplify this and then you will say what will happen to the maximum value of this particular expression. For this on expansion, I'm getting in the denominator, I'm getting 1 minus e by 2x plus x square. And in numerator, I'm getting 3 by 2x minus x square. Okay, so I get an easy idea here. Instead of doing S1 by S2, if you are doing S2 by S1, then this would be a bigger L because it is becoming 1 minus of 3 by 2 minus of 3 by 2x minus of x square divided by the same 3 by 2x minus x square. The resultant will be having 1 by 3 by 2x minus x square minus 1. So since we are trying to achieve the maximum value, let's say, this value in the denominator will be giving us maximum. We all know when a quadratic will give us maximum. Okay. And given the idea of S1 by S2, like which part to be kept as S1, which part to be kept as S2 was made by S. So we know for a quadratic, the maximum occurs at x equal to minus b by 2a. So minus 3 by 2 divided by 2a will become 2 into minus 1. So that becomes x equal to 3 by 4. At x equal to 3 by 4, this will give us the maximum value, right? If I divide it by that, so I'm getting 3 by 2 into 3 by 4 whole square. That will become 27 by 3 by 2 into 3 by 4. That's 9 by 8. 9 by 8 minus 9 by 16. 9 by 16 minus 1. 16 by 9 minus 1. So that gives us 7 by 9. We got 7 by 9. Right, so that's why S2 is 1. So when we reciprocate it, we can get to